Testing, testing the audio. But he can come. All right, everybody, let's get started soon. So please grab a beer and come closer. We will start the meetup. So, hello everybody, welcome to Futuris. And in the beginning of the meetup, I'm gonna say just a couple words about Futuris. So, first of all, some practicalities. There are toilets in the back, and then around the corner there are more toilets. So that's a good thing to know. And there might be a sauna after this meetup. I think it's turned on already. And yeah, I don't know if everybody knows about Futuris, but we are a consultancy based in Helsinki mostly, but we have offices in 8 different locations, and the most recent ones are Oslo and Stuttgart. And yeah, basically we do digital services for our clients. And one of the cool things about Futuris, why I like working at Futuris, is that we support open source. So we have this thing called SPICE program, where we basically pay our employees to work on open source on their free time. And that's pretty cool. And yeah, what else should I say? I don't know. We use React in quite many projects, like almost any company nowadays. And we like hosting these kind of meetups, so please welcome to Futuris. And next, Mike will be talking about Agile Search.
Hello everyone, my name is Mike, and we are the co-hosts of today's meetup, working in a company called Agile Search. We are an IT recruitment company that's in Helsinki, has been since 2011, and what we do is help a lot of local companies, IT and not IT specific ones, at finding the best talent in Finland or abroad. Very glad that you all made it here, and let AS maybe say a few things about our clients and details.
All right, welcome everyone. A lot of new faces here, so it's really nice. One thing that Mike didn't mention about us, so one of the things that we take really pride of is especially that we're tech recruiters, so we worked in the industry for like 10 years now. So at least one thing to know about us, that we won't mix Java and JavaScript, so don't worry about that. We actually know our tech, and we're very tech savvy. So at least Mike is a computer science graduate, and I used to work as a front-end developer, so we both know what we're talking about. So a little bit about what we're doing. So we work from small startups to big corporations here in Finland and Sweden, and mostly the companies that we work for are tech companies, or at least to some extent they're working with tech. So you see some familiar names like Finnair, Aura, Relics, Puff, Starship. They're the ones with the crazy robots. So that's a cool company. And yeah, so if you have any questions or if you'd like to talk with any of us, so me, Eyas, and Mike are going to be here around. So if you have any questions about jobs or anything, you can just have a chat with us. Nothing, no pressure, so it's going to be easy peasy. Just come and talk with us. So next we can talk about the speakers. So as you see, we have Mikhail Novikov, I got the name right, talking about Gatsby, and then Moral, and then we have Farzad from Futurize. So really interesting talks, and we'll be happy to see you all evening, and then afterwards we'll have some networking and grabbing drinks, and of course food if you didn't grab food already. Yeah, I think we can kickstart it. So should we start with Mikhail? Yeah. Yes, welcome. Here you go.
I have Does it work?
Yes.
Working? Okay, cool. I can just do the full screen. You have a clicker. How do you do full screen? Here is it. Yeah. How do you hide the top bar?
go full screen.
Yeah,
Which is this?
that's just the browser.
Oh, it's the browser.
There was some way to do it. I think we've been.
Yes. Yeah.
Yeah, it doesn't work. It's Mac.
Difficulties, as always.
Oh yeah, there's the top two things you need to.
And the other one. Yes.
Awesome.
Yay.
Well, whatever. Okay. Hi, I'm Mikhail Novikov. I'm going to talk about Gatsby and GraphQL and why GraphQL is used at Gatsby. A bit about myself. I'm Mikhail Novikov. I'm for Exonet in the internet. I'm software engineer at Gatsby. Working there in the core team, so I'm mostly working on open source. Or I only work on open source. Before that, I had a startup called Reindex. I did some consulting. I'm one of the organizers of React Finland. I'm a well-known person in GraphQL community. Contributed to many libraries. I have 2 cats. They're really cute. If you don't like cats, I hate you. So in this talk, I wonder if this started working. Oh well. In this talk, I'm gonna give a quick overview of what Gatsby is. Just hopefully lots of people already use Gatsby, but just to give a review. Then I talk about how Gatsby sources data during the compilation and why GraphQL is used for it. And then talk briefly about what's the future of GraphQL and Gatsby. So, quick overview of Gatsby. Who already uses Gatsby? Oh, that's very disappointing. Who heard of Gatsby? Awesome. Who wants to use Gatsby in their next project? Well, this is also very disappointing. But yeah, so what is Gatsby? Gatsby is a framework based on React. It's an open source framework based on React for building fast websites and apps. And it has lots of buzzwords, but I'll kind of quickly go through each of them. So React, it means you write your code and your pages in React framework. It means it's not just a simple React app. There are some things that Gatsby does. And building fast website and apps, I think this requires a separate slide. So Gatsby, some people say that Gatsby is a static site generator, which is not right, but I can understand why people have this confusion. So when you run Gatsby build, you get static assets with pre-rendered static HTML pages. So you can put Gatsby site on your CDN, even just the HTML pages, and you get a site that works. You don't need to have a server. You just need to have a CDN deployment. But together with pre-rendered HTML, Gatsby also produces JavaScript bundles. So why would you do that? Why would you destroy this perfectly perfect HTML with a JavaScript? Well, Gatsby HTML is not just HTML. It's actually a result of server-side rendering from React. But instead of running this server-side rendering every time in a server, we run it once, and then we saved a created HTML. And the JavaScript bundles actually contain the React code that, when you load the page, rehydrates the static HTML, making your app interactive again. This means not only that you load fast because you have static HTML pages that you just need to load instead of the whole single-page application, but also that subsequent loads don't need to reload the whole page again. There's no more full reloads after the first load of Gatsby website. Instead, Gatsby knows how to fetch the bundle for next page and quickly re-render it on the client. So you get the combination of static rendered site that is fast and easy to host, and single-page application that provides great user experience once you've loaded all the assets. So yeah, I've said that. So instead of having all the JavaScript be in one bundle, Gatsby automatically splits it per page. So you only need to load data for the page. And Gatsby also does some smart optimizations. For example, it preloads the links that are currently in viewport. So that in many cases, when user clicks on a link or navigates to a different page, this page has already been loaded because it's been loaded in the background. So to summarize the Gatsby, or at least that part of Gatsby, it's a framework to build sites that are easy and fast to host because you only get static assets. You can put them on CD and you can put them on S3 and CloudFront, and it's really cheap. You don't need to do anything. You don't need any servers. And you get great performance out of the box, both because those just simply HTML pages, but also because your subsequent loads use JavaScript and it works like a single page application without full reload and full re-rendering. And you can build static pages and interactive apps because at the end you get a React application when the rehydration happens. That means that you don't need to. That's why you shouldn't call Gatsby static site generator because even though that you get the static page, in reality your application can be as complex as you want. Also, Gatsby provides additional compile time optimizations. For example, it can generate source sets with compressed images for all different pixel densities, so you get all the images you need from one source image. And as I said, it's open source. And we have we have 6 full-time team members working on open source, and we have like 2,000 contributors to Gatsby right now. So we have very active and vibrant community, and we even send socks to people who contribute to Gatsby. So if you want Gatsby socks, you should contribute to us. So yeah, to have a tagline, it's Gatsby is compile time optimized web framework. It's like a compiler for your great apps. So let's talk about a different problem for static site generators. When you build your modern application, nowadays usually you source your data from different places. Usually you have an API server that does it. Because you have your e-commerce in Shopify, you have your edited content in somewhere Contentful, and maybe you also have an WordPress API. You need to combine it all and get one website that does it all. So that's what I was saying. And maybe you have your own custom APIs that also need, and your pages should render all this data. And there's lots of data, and your pages need to know what data they need. And they might need multiple different data. Like your index page might have your last 5 company blog posts, but also it might have the 5 products you are selling in your shop. Or it might have a documentation to your framework. And most probably you don't want to have all the data inside your pages. For Gatsby, it's not that big of a deal because Gatsby is pre-rendered. So this only happens in compile time, but if you pretend it's a normal single-page application and you have to query the whole world to render it, it's obviously pretty bad, especially on mobile. And ideally, you wouldn't want to write custom code every time you want to query something. So you should have an API that's unified, that there's like one way to query the data from all the sources. So yeah, this is what GraphQL is for normal APIs. This is why people use GraphQL and build API servers. They want to have data granularity, they want to source data from different locations, and they want a unified API that their frameworks can use. And Gatsby uses GraphQL too. So Gatsby has this ecosystem of source plugins. And source plugins, they can be for things like Contentful, they can be for things like WordPress, but they also can be for things like file system or for things like Markdown pages. And all those sources can add the data to your Gatsby site. And then once the Gatsby gets all this data during the compilation stage or during running Gatsby develop, Gatsby goes through this data and it generates GraphQL schema, one unified GraphQL schema with which you can get and query and introspect the data that you get. And that schema, because Gatsby generated a schema, there's like unified interface, unified API of how this is done. I mean, GraphQL is already uniform, but also, we can write all the different kind of GraphQL schemas, but Gatsby schema is always the same. Regardless of what kind of data you query, you can be sure that there will be same way to filter it, there will be same way to query for it, same way to create relations. And once you get the schema, once you get the GraphQL schema, your pages can actually query this data through GraphQL during the compilation time. So each page in Gatsby also exports a query. And then this query queries for data inside the Gatsby data, that Gatsby cache that was collected from all these different sources. And then it's queried to GraphQL. So this is why Gatsby uses GraphQL. We need one query language to get all the data. And most apps now have different sources, not only one. And when you have very simple blobs, very simple application where you have only like markdown files and you want to write a blog, maybe something like Jenkins is simpler. You don't need to have GraphQL, you need to write GraphQL queries. Jekyll, not Jenkins, of course. But once you go into real world, and once you have more people in the team than just programmers, you need to source all this different data. You need to source stuff from CMSs. That's when having a unified gateway for this becomes useful. And with Gatsby, you don't need to build it. So this is a very beautiful picture. All the different sources going into Gatsby, and then with the magic of GraphQL and React, you deploy it to the CDN, and you get beautiful React application. So Gatsby isn't just a compile time optimized web app. It doesn't produce only that. It's also a compile time API gateway. It's an API gateway you don't need to build anymore, because you can get all this data from different APIs in Gatsby. And as this compilation happens during your build time, not during your runtime, you don't have to care that you're like going through all the sources, because this will happen much more rare than people visiting your website. And then this data will just be there compiled into HTML page once they do. Finally, I want to talk a bit about future of GraphQL at Gatsby and what we are working on. First thing is schema customization. As I said before, Gatsby schema is generated from the data you have. But this can be a problem. We want to give people more control over Gatsby schema, especially over the inference, because ununiform data can cause inference issues. And with schema customization, you can define parts of your schema that you know and that you want to be fixed, and then you won't have those issues anymore. And plugins like Gatsby Source Contentful can use it to generate the schemas themselves, also simplifying and improving performance because we no longer have to introspect the data to generate the schema. Then the hot topic in Gatsby themes. Gatsby themes are like starters or boilerplates, but there are also a library. You can compare Create React App and React boilerplate. Gatsby themes are Create React App that you can compose and have multiple ones on your page. So there can be Gatsby theme blog, with which you can create a Gatsby blog by just importing it. But then if you also need e-commerce, you can add Gatsby theme e-commerce, and then they will compose together, and you don't need to do anything else. You have the site that both blog and e-commerce, and you can override parts of it. And the thing we're working on in terms of GraphQL is theme data types, which would allow themes to also define what kind of shape of data they have. And then different sources can fulfill the themes. So you can have Gatsby blog, Gatsby theme blog, but then you would also have Gatsby theme blog contentful or Gatsby theme blog markdown, and you can have half of your blog posts in contentful and half written just as markdown files in Git. With which we are moving from what I call source data types to semantic data types. If now Gatsby schema types depend on what kind of source plugin created them, in future they would depend more on what they're used for. So something like markdown remark would become blog. Yeah, thank you.
Okay, so any questions? Yeah, but yeah, let's take this cube out of
Can
here.
I throw it?
Yeah, I think you can. So throw it to someone.
Okay.
Hey, you told about the process of using a CMS like WordPress and a plugin to load data, and then it gets converted into this unified schema that Gatsby uses. And on build time, all of that data is being generated to the static HTML, right?
Pretty much, yeah. The one that's used.
So how would you like take the step forwards on actually having an application where you rewrite the data that, or is it even possible because we're just dealing with
What do you mean
data?
by rewrite the data?
I mean, if I would like to, or is it just a static page? I mean, could you actually, because it's compiled to static HTML, so you cannot really access the
Yeah,
static.
it's compiled as static HTML, but practically it's still a React application. So whatever you can do with React, you can do with Gatsby. So if you want to do something with the data, like make an interactive app, you can do it. It's just that you you still get the static pages. So you still get the high performance, but then at top of this, you can build any kind of interactivity you want. So like at the end, it is React framework. It's like 100% React. There's nothing special except the fact that it generates it. And I said it's like React server-side rendering, but done ahead of time. Instead of being done just in time, like normally when you load the server page, it does server-side rendering, and then it goes React here. You got the result of the server-side rendering as files, and then this becomes like a full-fledged React application.
Okay, that sounds really cool.
Okay, any more? Just throw it there.
Hey, just to follow up then regarding the static content, if that was like something like search, something dynamic that produces different results over time, what are the ways to deal with that content?
Yeah, there are multiple ways to do it. Like depending on what kind of search you want. Because you can either, if it's a search that's kind of faceted by something like tags, then, and the number of tags is not like billions, then you can just pre-generate the pages with basically search already done for that. So if you have like a taxonomy of stuff like categories or tags of blog pages, you don't need to actually use full text search every time because you will have the page for each tag. That's like one side of the question. And then if you actually need the full search, we have plugins, for example, for Algolia, and those do happen interactively. They search through Gatsby nodes and Gatsby pages, sort of index them, and then you can kind of associate the pages to the node. And then there would be like a full JavaScript interactive search, and then you kind of redirect people to statically rendered pages after they find something.
Okay, thank you.
Any more?
There's someone there.
Let me just get it. Okay. Who was it? There.
My question is, would you start almost any new front-end projects with Gatsby?
Yes. There are some projects that are less sort of. There's a scale, like sort of you can do any React project in Gatsby, but there is a scale of how much it helps you. Like the more static your website is, the more optimizations Gatsby gives you. So something where you have 100% interactivity, like maybe I don't know, an editor. There are no fixed pages there. It's like just one page, and you have an application that doesn't have sort of a concept and pages inside. There, Gatsby helps you less, even though it's still like it's like React framework, but there's no point of doing it because you will have one HTML page and you will have full page application there. So that's kind of one scale. Another scale is how often it rebuilds, because if you have data that's so fresh that you need to refresh it every second, like you have a stock ticker, then you need to rebuild in Gatsby. That means that you spend like 2 minutes or 5 minutes to rebuild it. And we are working on this to make it fast, but still it will never be like milliseconds. So if you have something that's like, really, really up to date, and all your website is like that, then again, Gatsby is less useful. However, in many cases, not your whole website is so interactive. Because you have lots of static pages, then maybe you have one part that's interactive. Like you can imagine something like e-commerce, where the checkout process is interactive. And maybe checking if something is in stock is interactive, but everything else is still like static pages. So there Gatsby helps a lot, even though some parts of it can be supported directly by Gatsby.
Thank you. We're building an e-commerce site with Gatsby at Stirp. Thank you very much.
Okay, so any more questions? You can try it. Yeah. Okay, you got it.
True. So this use of GraphQL was really interesting. I was wondering, like, on which phase is the GraphQL available? Is it only on compile time, or do you serve it on the static host, or do you serve it on a active host, which is then separate from the static host?
In production, it's only served on compile time. But in development, you have it available when your develop server running, so you can also use it directly to, like, for example, in graphical and check out what data you have in Gatsby.
Okay, awesome. Thanks.
Okay, one more question and then we continue. So who wants to do that? Okay, there.
Okay, so I don't think I'll have the chance to use Gatsby at work, so I'm thinking more of like for a personal project. So let's say if I wanted to, I don't know, do like a blog. So why would I choose Gatsby over doing like a plain old WordPress blog? Is it other than trying something new for fun? Like, is there something like concrete benefits that I would see?
You don't need to install WordPress or make a WordPress account. You can put it on Netlify and it will be there and it will work and no one will hack it.
I can put it where?
Netlify, for example,
Okay.
like some CDN,
Okay.
and no one will hack it and no one will put something bad on your pages,
Okay,
unlike
fantastic.
WordPress.
Thanks.
Okay, so that's the questions. Let's give some applause to the Mikhail. Okay, so next speaker. There, yeah. Okay, so it was some moral thing, something I don't know, but let's see. Yeah. They didn't tell me anything beforehand, so. Okay, so I'll let you do your talk, and yeah.
Spoilers. Okay, so hi everybody. This talk is going to be about web development and moral philosophy. So not exactly your usual React Helsinki type of talk, but we'll see how it goes. So a bit about me. I'm Igor Sukinski. This is not me. This is Cassiopeia. Since we're flexing cats, I decided to flex some too. I'm a full-time human being and occasional web developer. Right now, I'm not associated with any company in particular. So this talk was heavily inspired by an article in Smash Magazine titled Using Ethics in Web Design, and I encourage you all to check it out because it was written by much smarter people than I am, and it's much more comprehensive, and I simply don't have time to cover nearly the amount of topics presented there. But I want to give a brief overview. So what is this talk going to be about? This talk is going to be mostly about morals and ethics and how they affect our lives as developers and how we as developers can use them to affect lives of other human beings. In this talk, we'll cover some very broad concepts. We're not going to delve too deeply, really, because we don't really have too much time. But we'll discuss a descriptive versus prescriptive approach to discussing such topics. We'll discuss the difference between morals and ethics, and we'll discard it right away because it doesn't matter. And we'll check out some different ethical frameworks, how to use them, how to, see if what you're doing is good. see how they apply to our day-to-day job, and how to avoid common pitfalls when thinking about such stuff. Just to let you know, I'm not going to tell you, how to be a good person or how to do good things. I'm not trying to do the prescriptive thing where I say, this is good, do this. Use this approach, it's going to lead to good result. I'm not here for that. I'm here to give you tools, frameworks, if you will, that help you evaluate your choices, decisions, your technical and non-technical things that you do every day. And this is heavily related, we're going to philosophy straight away, I'm sorry. This is heavily related to is-ought problem, which was first outlined by David Hume in his Treatise of Human Nature. And it's basically, he noticed the contradiction that most philosophers, when talking about moral philosophy, they describe how things are, and then they kind of go ahead and jump to how things ought to be, how things should be, without really explaining this jump. And he argued that this jump is impossible to make with logic. It's impossible to base this jump on facts. In order to describe how things should be, you need to consult your inner convictions. You need to basically speak to yourself and decide for yourself how things should be in the world and act based on that, based on how things are right now. So what I want to say is, again, not trying to tell you how to be a good developer, how to be a good person. What I am trying to tell you is, here's a bunch of approaches, here's a bunch of frameworks. Use them or not use them, that's up to you, because only you can decide what you should see in the world and how you would like it to be. So, quickly go over morals and ethics, because those are very important terms that are often mixed up, and we're going to mix up them a bunch, because that's not that's not terribly important for us. But just so you know, morals are usually thought of as something personal, something that you decide for yourself. You're like, okay, those are my morals, those are my standards, I'm going to act on them. Like, being vegan, for example, is a moral choice. It originates from Latin mos, meaning custom, which is kind of backwards way of doing that. But it's individual, it is up to you. And ethics is something that concerns us a lot more as developers, because ethics is cultural, it is social, it is communal. It is a code, a set of rules that we define for ourselves. Say, doctors have their ethics. Like, their number one point on their ethics is do no harm. We as developers, we don't have such strict codified rules, while engineers, for example, and journalists have. Maybe this is a problem to rectify, but certain communities have certain codes of ethics that they use. But in philosophy, those things, moral philosophy and ethical theory, ethical philosophy, they're usually, used indistinguishably. They usually mean one and the same thing. Doesn't really matter a whole bunch, and we're not going to meander in this distinction. There's going to be code, yes. It's not real code, it's pseudocode, but since we're all developers here, I think it's better to understand what we're talking about exactly. So this is my simple definition for morals. It's basically a function that takes an action and outputs a number. So it gives you a moral judgment. An action can be a word, it can be something that you do in the world, it can be, even in some schools of moral theory, it can be even a thought. It can be an intent, whatever you want it to be. Basically, however you act in the world, whatever you do is a subject to moral judgment. About almost anything you can say that it's either moral or immoral or outside of the moral boundaries, and really, it really doesn't matter. The morals do not judge it. So the simplest way to define it is literally, you get an action, you output a number. So I'm here at React Helsinki, so why give this talk at all? Because there's a bunch of very, very interesting questions about development ethics that we can discuss, and spoiler, we're not really going to answer those questions directly, but I want to give you tools to answer those questions by yourself and to, make you ask those kind of questions all the time while you're doing your job. So question number one, is it ethical to continue supporting Internet Explorer 6? It is, based on some school of thoughts, it could be considered ethical or unethical. And it is quite interesting to think about that and to base your decision not just on a perceived monetary value, but also on your internal values that you hold. Is it ethical, for example, to relicense existing open source code under Common Clause, which prohibits corporations like Amazon from using them for free in their data centers and in their clouds? It is also not just a legal question, but an ethical one, because it's not a decision made by faceless corporation, it's a decision made by humans, and developers have a direct, I wouldn't say responsibility, but input in those decisions. We write the code. We can, up to the point, decide what happens with it. This is also like a question that we could answer. Is it ethical, for example, to exclude people from open source projects based on their behavior on Twitter? Was also quite a hot topic. And again, it was mostly discussed in a way that, you know, employs a lot of slippery slope arguments. And if we start doing that, then we'll soon ban everybody for wrong thing. But we can think about those questions not just on their outcomes, but based on how do they align with our values and how we evaluate whether those actions align with our values. And the most important question of all is, of course, is it ethical to build a chat app that eats 4 full gigs of memory? Spoiler, it's not. So let's view some ethical approaches developed by smart people and see how we can utilize them in our day-to-day developer lives, or not utilize them if you so wish. Utilitarianism, by far the most pervasive approach in this profession and in the corporate culture in general. It is an approach that's basically a default one. You most likely are using it without even realizing it. It's a form of consequentialism, meaning consequences are the only thing that matters. An action is good or not based on its consequences. And nothing else matters at all. And with utilitarianism in particular, the aim is to maximize well-being. The aim is to do an action that's leading to the maximum total happiness in the world. If you're doing an action that decreases total happiness in the world, you're doing a bad thing. If you're doing an action that increases the total happiness in the world, you're doing a good thing. So it seems pretty solid, right? What else do we need? Well, first of all, let's look at some code. And this is my pseudo function for utilitarian moral judgment. And as you can see, everyone here has a red squiggly line, and that's not just because I was lazy, I didn't define it in my editor. That's because it really is a problem with utilitarianism. Who do you define as everybody? Right? When we are developing software, we're usually thinking of everybody as users. We're usually not thinking of, I'm going to build this software for all the human beings in the world, and it's going to be used by literally everyone, and it's going to increase well-being for literally everybody. We usually confine our judgment just to users. So if users, for example, are happy, but non-users, as a result of our actions, become less happy, then utilitarianism is kind of blind to this concept, because we have restricted our domain. We have said that, hey, our everyone is not just literally everyone. And this, let me go back to it. This is a problem that is seen not just in development, obviously. It is also seen however you apply utilitarianism. If you apply utilitarianism as maximize well-being and happiness for all human beings, then what about non-human beings? What about human beings who are incapable for some reason of experiencing happiness? Do we just ignore them? And this approach has blind spots, and as we will see, basically all of the ethical approaches have blind spots, and being aware of them leads us to better decisions. So utilitarianism was created by this smart-looking bloke, Jeremy Bentham. He was really into pleasure and pain, as you can see from this quote. He said that nature basically put us onto the governance of pleasure and pain, and humans are basically ruled by pleasure and pain. And so, as human beings, we should seek to maximize pleasure and minimize pain, and that's the only thing humans should do. And that's basically his philosophy. So because of that, there are major pitfalls such as whose happiness are we considering? Are all human beings included or some are not included? What about, like, for example, unborn humans? And another major pitfalls of utilitarianism is if we're just thinking about happiness, what about other non-utility qualities that we think are desirable, but we can subtly avoid? For example, say you build a search engine and you decide to monetize it with ads. And because ads monetize well when you collect a lot of information on your users, you collect a lot of information on your users. Your users are happy because they have access to a high-quality search engine for free. But you are subtly collecting information on them and building profiles, and that basically doesn't really affect their daily lives, so it's cool, right? But also, you might think that it's a bit yucky, and utilitarianism is just completely blind to this yuckiness. It's completely blind to restricting rights or freedoms. And because utilitarianism is #1 philosophy of corporate entities, as you can see here, because, corporation thinks that happy customers lead to prosperous businesses, which means that if your business does well, we are doing moral good. That could lead to problems. And if you, as a developer, adopt this corporate mindset, you could contribute to something that you don't want to contribute to. Again, not to say that, stop working for bad corporations or whatever. That's not my point. My point is, be aware, and when you can make decisions that you think are good, make those decisions. And here's an example of how utilitarianism is blind to problems within specifically, again, tech industry. For example, people in developing countries might not have access to new apps because they have old and inexpensive phones. And because we just decided, supporting old phones with old operating systems is, that's not something we want to do. That's not something we want to spend our time on. And by this measure, we are excluding those people. And this decision, it totally makes sense, don't get me wrong. The happiness of people who are actually using this application goes up, while the happiness of people who don't use this application is not affected in any way. So, we are utilizing our resources efficiently, but are we doing good? And are there other approaches that can help us solve this contradiction? We can try fixing utilitarianism by applying it to our daily lives and thinking about how it affects other excluded groups. So we can prioritize increased utility for everybody instead of just for the majority, which is not strictly maximizing utility as we discussed previously, but it could lead to better outcomes. Think about minorities, and I'm not just talking about, various demographic minorities. I'm talking about minorities such as people with Internet Explorer 6. They are the minority. Or how about people who need to use assistive technology in their browser? People who are using screen readers. Is your website optimized for them? If it's not, well, I get it. It's just business. But thinking about it as just business precludes us from thinking about bigger moral pictures. All right, I'm seeing you're all having fun. Let's jump into some more fun with deontology. It's even more nerdy. It's basically complete opposite of utilitarianism. Consequences do not matter whatsoever. What matters is rules. You're following rules, that means you're good. What those rules are and how those rules are defined, well, that is the other question. But a good example of rule-based ethics that web developers are actually following semi-consistently is following web standards. Nobody forces you to follow web standards. Browsers will happily eat just malformed HTML. You can do some very wonky stuff in your web pages, and browsers will render it and work with it just fine. But we're following standards because, well, of course, it leads to some common good, but mainly because it's the rules. If there were no web standards for us to fall back on, we would have to invent them. And this is where deontology comes into play. Sometimes a decision cannot be really made individually in order to lead to the best outcome, and we have to invent some rules. So basically, in order to make a moral judgment based on deontology, you just get the rules and make sure that whatever you're doing follows all the rules. Like, for example, use web standards. Use linter, sorry, whatever. Again, of course, this approach and the pervasiveness of this approach in some communities also leads to pitfalls that we can be blind to. As you can see in this code, rules has a red squiggly line, and you know what that means. That means that this is a big question that needs to be answered. What are the rules? Who makes the rules? Where do we get those rules? Do we rely on authority all the time? That doesn't seem like a good idea. Web standards exist because there is an authority that makes web standards. That's good, but what if there isn't such an authority, or what if you're disagreeing with it? Can we rely on whatever makes the rules to be moral and just? Can we rely on it, providing us with what we need to do good? And are rules just, rules in the vacuum? Does it not matter at all what the rules are? Or is there some other moral foundations for us to build rules upon? And this is where this nerd person comes into play. His name is Immanuel Kant, and he developed a thought experiment, a device for basing rules on strict logic. Developers love it because there's absolutely no feelings involved, just pure logic and reason. It's called categorical imperative, and it's a real tongue twister. Act only according to that maxim, by which you can also will that it would become a universal law. It doesn't even look like proper English, but in a proper English, it's basically sounds like that. Imagine a rule that your action follows. If you can make this rule into a universal law that everybody has to obey, then this action is good. If you cannot, then it's not necessarily good. Here's an example for you. You're building a web application, and you are thinking about giving a go to a linter of some sort, so that it's gonna, scream at you whenever you don't put a semicolon at the end of the line or something like that. This is very much a rule-based approach to software development. You decide to put constraints on you. And you're thinking, well, if I have to use a linter, then everybody else has to use a linter too. And the total health of the project, total health of our community is going to increase as a result of that. Therefore, using linter is good. If you decided to use some other tool by yourself in your project, but you just couldn't make it into a universal rule, or didn't want to for some reason, like say you are using a proprietary test automation thingy that only you can use because of financial constraints and nobody else on your team can use it too, then according to categorical imperative, this is not a moral act, because this is not something that you can make universal. This is not something that you would want to make universal. So that's pretty much, grounding the logic of deontology on itself, and therefore basing it not on feelings but on facts. It doesn't really work that well in the real world, but we can use it, and it can lead to some improved outcomes for us. So how do we apply deontology to web development? Well, follow existing rules, best practices, and guidelines. First of all, they are here for a reason, and secondly, if everybody uses them, then everybody's outcome increases non-linearly. If you're the only person who follows the rules, they are useless. But if everybody follows the rules, then they are suddenly transformative. And that's the point of deontology and rule-based ethics. Making rules universal leads to significantly better outcomes. If you want to create new rules, if you, for some reason, don't really have something to rely on, you have to make a call, a judgment, and this judgment doesn't feel like it's like a singular, isolated event. It feels like it's going to happen in the future again and again, and you're going to have to make some standard, some rule for others to follow. When creating this rule, think about categorical imperative. Is it good if this rule becomes universal? If I'm making a new rule, does it lead to improved outcomes for everybody if I can, by some magical will, force it upon everybody without choice or question? If the answer is yes, then yeah, definitely do that rule. That sounds like a good rule. Also, use some existing ethical principles. We're not strictly logical creatures. We all have our moral convictions. We all have our differences. So basing the rules that you create not on some abstract logic or something, but on those convictions that you hold, is also not a bad idea. Maybe it will lead to a good outcome in the end. And finally, the unspoken rule of any craft, any trade is duty of care. This is not really a rule that's codified anywhere for software developers, but this is a rule that we are somewhat following, and I hope that many of us follow it already. Basically, care about your clients, about your users, about your teammates, and about the information in the future in general when you're building software. That's a very vague rule, but it's a guideline. It's a guideline for you to follow. And I promise this is the last one that we're going to cover today because, again, having fun. But this is virtue ethics. This is the oldest, and it's the wankiest. But it also gives us pretty good results in some cases. So basically, Socrates is thought to be a progenitor of virtue ethics, and basically it states that no, consequences do not matter, and rules also do not matter. What matters is that doing this act makes you a good person. An act is good if by doing this act you become better. You better yourself. It's kind of like, what would Keanu Reeves do in this situation? This is virtue ethics. Think about what a virtuous person would do and do that. So, as Socrates probably once said, a virtuous person is one who acts as someone who holds these virtues. Act as you would want your best version of yourself to act in the situation. And how do we apply them to being a web developer? Well, we identify some virtues of a web developer. We identify what makes a good web developer, and we try to act as if we already are. So, I'm not. And so this list is just, me thinking about something on the top of my head, but you can think about it too, and you can decide for yourself who is the best version of yourself as a web developer. How do you see it? And so for me personally, virtues of the web developer would be knowledge. A good web developer knows their trade. They know how to build stuff and build it well. It is truthfulness, not lying to yourself about your capabilities, about your deadlines. And I'm not casting shade, but I'm pretty sure everybody lies to themselves about deadlines. Collaboration, some camaraderie with your fellow developers. Open source is thought to be a virtue. And I think that's for a good reason. Care, as we discussed in a previous section, caring about your clients, your users, and people in general when working, that sounds like a virtue to me. and a bunch of others. But again, I'm not trying to push anything down on you. I'm just saying that you can decide for yourself and you can try to follow these standards, not because I said to, but because you might see that it leads to better outcomes in your professional career, and you just might sleep better at night. Act as a developer you want to be is basically how we would apply virtue ethics to software development. And that sounds like a good idea to me. And I know, like, I'm looking at you. This is the question that everybody's asking. Like, so what? We're developers. We're at React Helsinki conference. Why is it even relevant? What's the point of this talk? So the point of this talk is give you tools, give you frameworks, let you use those frameworks in your day-to-day professional lives. Ground those concepts and frameworks in familiar for you experiences so that you understand them better and that you see for yourself whether they are useful for you or whether they're just like, that's sophistry, I don't really care about it. That's a valid reaction, but at least it's an informed reaction, right? It's better to hear about it and decide that I don't need it than not hear about it and make an uninformed decision like that. And, why use philosophy at all? Here's a great closing quote for you. The philosophers have only interpreted the world in various ways. The point, however, is to change it. So, using philosophy not just to think about your decisions, your actions, your work, but using it as a tool to change the world in a way you want it to be changed. That's what I'm hoping to convey today. So, the quote is by Karl Marx in his 11 thesis on Feuerbach. It's also written on his grave, if you're interested. So, that's it from me. Thank you very much for your attention.
Okay, maybe I got it on. Yes, I did. Okay, so questions.
So that would be a question maybe to everyone, but to you first of all, because when trying to convey some message, it's normally good to start with yourself. So the question for everyone would be, when we look for a job or like we learn about companies, we look at the corporate websites. And in many cases, there are like values pages or corporate culture pages. So how important is that for everyone? And how does that relate to your talk?
Well, I can answer for myself, and everybody else can just think about it or answer, I don't know. Corporate values are definitely important because companies are, they are small sociums. They are groups of people that are doing something together, and those groups inevitably form some common cultural background, some ways of working together, some ways of communicating with each other. And those values definitely exist, but in my experience, those values are often not exactly truthfully expressed in those, corporate messaging pamphlets when you're trying to get a new job, because we all have to remember that corporations exist to maximize profit, not to create value for humanity. Well, as a rule, there are exceptions, but they are exceptions and not rules. And so those corporate values that you see, you have to treat them skeptically. They might look nice, but they might not be what they seem to be in the real world.
So you don't see people behind those words? Like some companies claim that they want the world to be a better place?
Almost every company claims that. And that claim is, well, it requires a lot of scrutiny in most cases.
Okay. Anyway, any other questions? Oh, I can take it there. And yay, first glass broken.
As you, hello, hi. Thank you for the talk. It was quite nice. I want to ask about React. So,
Yeah, that's a good question.
yeah, do you think should we use ethically React? Because as you just mentioned about the companies, corporates, like they are just providing some nice value. They show something pretty good, but behind the scene they are doing something fishy or something different. So as we all know, React is from Facebook, and they also hold over all the information. So what do you think? Should we use React ethically?
That's actually a great question. That's a great question. And when it comes to deciding to use a particular technology, I think a more important question is not what company is producing this technology, what's the origin of it, but what's the effect. As you know, Facebook had some icky licensing issues a couple of years ago when it had a patent clause in this license that made it technically non-open source. That was at least somewhat affecting the end product. It was at least somewhat affecting people's ability to use it without fear of retaliation for Facebook, without fear of, if you're building a competing Facebook for some reason, won't they just close you if you're using React? That was a legitimate fear. Now, there are protections against that because of the current React licensing and because it's a community project and not just a Facebook project. So while you can think all you want about Facebook as a company, React as a product, you can judge it on its own merits because my opinion is it's far enough removed from Facebook, even though most of the contributions to React is from it. But the question is not whose contributions are they, but what degree of control do they have about it? Like, if they just decide to relicense it and re-release it as a proprietary product tomorrow, then we'll just develop a fork. That already happened with OpenOffice, for example. Not exactly like that, but still, React is mostly safe, I think, and we can judge it on its own merits without thinking about icky Facebook stuff. That's my opinion.
Okay, any more questions? Oh. I'm not throwing it anymore.
Speaking about judging products on their own merit, it's clear with React, but by the same logic, should we be cautious about using NPM? Because NPM is a product of a private corporation that just happens to control most of the open source web development commons.
Yeah, that's also a good question. I think I've also read the same article. But yes, a very valid question. And here, of course, making a moral call, making an ethical judgment is not impossible without looking at the actual material conditions that we exist in. And the conditions of JavaScript developments are such that you can't not use NPM registry. That is not an option as of right now at all. So building a competing, distributed, community-controlled tool registry is something that I would get behind, but abandoning NPM, I think, is uncalled for because, well, it is called for, but it's not really something that we can do, is it? Like, you can't just, you can build a website in pure JavaScript. You can download the source codes from GitHub manually and you can build them and whatever. It's not going to work. It's not going to work. You're not going to build a successful product. And if you are building something that you think will lead to good outcomes in the future, then using NPM is just something you have to contend with. Ethical consumption and all that.
Thanks.
Okay, if there is just a kind of very small question, so is there? Okay, there is not. So let's continue and let's Hans. Okay, so we will have 15 minutes break now. So please be back in 15 minutes. If you're not, we will start anyway.
Hello. Just a quick note that there's more food left, so feel free to take more and drinks.
Boop, boop. Yeah. Okay, so people, please come closer if you want to. You don't have to, but I would suggest you to do that. Hey. So the next talk is about to start. So are you ready? Okay, it's not ready yet. But don't worry about it. We will get it started soon, maybe. Or maybe not. This never happens anywhere else. Only everywhere I go. Okay, so let's give a big hand to Forza for presenting the next one.
All right. Hello, everyone. My name is Farzad Yousefzadeh. I'm originally coming from Iran, but I relocated here more than a year ago, and I work as a software engineer in Futurize right in Helsinki. Please do follow me on Twitter if you like what I'm talking about today. I want to be the next thought leader in JavaScript community. So a bit of history about me. I used to be an astrophysics and pure physics student at university, but then I dropped out of college at the last semester because I figured out this is not how I want to live my life. And I was studying astrophysics and aerospace engineering at the same time, indicating the telescope and the airplane. And then I started self-teaching myself on the web to how to do web development. And a couple of months after that, I learned how to do basic stuff. I got my first job, and almost 7 years after that, right now I'm here. I work at Futurice, as I said, and I like the Finland's country, but I heard from someone today that you need to survive the 7th winter. Well, let's see. Yeah, so a while ago, I developed a really dummy project called HSL Zone. And it's already deployed on hslzone.netlify.com. As it comes in the name, this does detect the zone based on the HSL data. So what it does is that it gets the GeoJSON data, open data from the HSL. And this is the visualization of how that data can be previewed on a map. So basically, HSL will give you the points on the borders of different zones here. And as you can see, I'm not sure whether you can see it there, but if you can see my pointer here, yeah, this is the A, this is the B zone, this is C, and these from here and that one are D, both of them at the same time. So HSL gives you these points on the borders, and based on the current geolocation of the user using HTML API, you can, with a bit of mathematics, you can detect what zone you're in right now. So that was my point. I started that as a really dumb side project to just give React hooks a go to see how it works. And surprisingly, it went well. So yeah, I had a spec. So I put this list in front of myself to say that, OK, this is going to be the thing I'm going to develop. So I wanted to detect your zone based on the geolocation. And then I want to let the user to manually redetect the zone whenever they want it. So when I detected your zone, for example, if you're in zone A, I wanted to give you a B, but like a button for refreshing that. So if you change, for example, to B, and then you want to make sure if the app is correctly working, then you click on the refresh button and it will give you the B. Not useful, but. And I wanted to have a feature in the application so that it could watch for the geolocation changes and tell you that, hey, you're changing your zone, or your zone has changed, and this is your new zone. I also wanted to go a bit farther and then send local notifications when you had the website on the background, and then tell you that, hey, you know what, you changed your zone, make sure to like check your tickets or whatever. But there were some hidden evils. It was not as easy as that spec. For example, geolocation support. If you've ever used JavaScript and HTML5 APIs, you've known what I'm talking about here. Not everything is supported everywhere. Platforms are evil. So I need to check whether the browser that the user is opening the website in has the support for geolocation or not. Then I need to check whether there is a notification support or not, because notification is surprisingly not supported everywhere. And then another evil nested there was that you had to check for the notification support only when you were watching for the location already, and there was a change and there was an update in the location. So there were a couple of conditions there. I didn't want to just like check for the notification support if there was no need for it. Then there was another evil there. I wanted to initialize the notification based on the permissions. I didn't want to bother and annoy the user asking for the permission all the time. If you've given me permission for the notification once, then if I ask you again, you would be probably angry and just remove that permission from me. And then the manual refresh should have turned off the watching. So for example, if I have detected your zone to be the zone A, and you said that, okay, now just watch for the geolocation changes. Then there was a geolocation change, and you manually clicked on the refresh button that I previously mentioned. Then you need to I needed to turn off the watching automatically. So these were the hidden evils and the points in the application that even though the application was pretty simple and straightforward, these evils would have made it really buggy. There were also some errors. There were zone detection errors. I could have made some problems in my calculation. There were some geolocation watch errors. What if the geolocation callback was hitting errors? And there was also notification errors. But some errors, like zone detection, were critical because if I couldn't detect the zone based on the geolocation, I needed to handle that explicitly and show something different to the user. But notification and geolocation errors were kind of like silent because if I didn't detect, if like the geolocation callback was hitting error, what could I do? I just had to continue with the current state. Same for the notification. If I failed to send you the notification, you wouldn't care. I can't just alert you, hey, notification sending failed. Because say, well, so what? So these were like hidden errors, and they were you should have treated that silently. But that zone detection was a pain in the butt. You should have critically handled that. So my first attempt was, of course, a very naive attempt. So I tried to model everything at different booleans, trying to figure out if the geolocation is supported, if there is an error. If there is an error, then it's either the position error or the zone error or the notification, and there is a zone. And then I needed a way to figure out whether I'm in the middle of detecting something or not. But obviously, this doesn't work. Why? Because I'm relying on derived states. I'm not explicitly saying which state the application is in right now. I'm just trying to derive the current state based on some data in this object. There was another problem. I was grouping irrelevant stuff together. I should have only grouped them when they were updating at the same time. Obviously, all these data and these properties in the same object, they don't update at the same time. So all the operations needed to take care of a part of it. So that was kind of like an anti-pattern, and that will end up with an unmaintainable code. So I tried to refactor. I tried to think about the states. I tried to say that, okay, if my application is dependent on the state of the zone, then I'm either idle, so it means that the user hasn't clicked on anything yet. He just opened the application. And then I could have been in the pending. It means that I was in the middle of detecting the zone based on your geolocation point. Or I could be in success, so I gave you a detected zone, or I could have an error. I also had another state for watching, because the watching was kind of independent from the zone detection. You could treat it as some like independent part of the application. So it could have states, so you could either not watch the locations or you could watch it. There was also notification as well. So the interface of the zone state ended up as something like that. A bit more compact, still has some room for improvements. But this refactoring had a benefit. It was more explicit. I at least knew that what state my application is in right now. I'm pretty sure that most of the developers, when they're developing using React, they don't even do this refactoring. So this is a huge win already. Then I needed to react to certain events. So I tried to define the events that the application could react to so that I could do some side effects in react to those events. I could detect the location and set the zone to success and error. And if there was an error, there was probably a payload for the error for the reason. There was watching the location. And then I could have like requested for notification permission or set the notification permission, whatever it was. I obviously had to cut a bit of these events because it would have just expanded and I couldn't just show it in one image here. This refactoring enabled me to, instead of thinking about my view as a living React or JSX element that could alter the behavior based on some certain state. Instead of that, it enabled me to define it as a mapping. So what I ended up having in my view was that instead of having my screens to be a certain static screen that had different conditionals inside of it, instead of that, I could just map it because all my screens were independently living from each other. Because since I refactored my application to have different states, those states were mutually exclusive. It means that they couldn't happen at the same time. So the screens could also not happen at the same time. It makes it really, really readable because I know that, all right, if the zone state is idle, I don't need to render anything else. So if I hit any bug later on, I know that if I'm in this state of idle, I don't need to check the rest of the code. I know that if there is a bug, it's there. And the reason I'm using the word term send event there is that, well, I don't kind of like the advocated word dispatch because dispatch means you're dispatching an action, and the way that Redux or use reducer in React work, they're not dispatching any action because action truly means side effect, but they're not side effect. They're pure signals. They're events. So it enabled me to have use state mapping. All right, but let's think about UI. In order to make a UI, you have different ingredients. You have a view. In this case, it was React. You have a state. In this case, again, was React. And you have some side effects. And these side effects can vary between different libraries and frameworks. And you have an interpreter logic, because this logic needs to take, this is basically, the logic is the core of your application. It means that it gets the state from you, and based on the state, it runs a side effect, and it produces some output that could be the view. And there are some REST stuff, like styling and other things. Let's take a look at the hooks implementation. In order to implement it using React hooks, I decided to use reducer, because that was the sane choice of tech in this scenario, because I couldn't just split it into different user states. So I ended up having one interface for my state object. I had error and zone state, watch state, exactly the same type I showed you in the previous slides. And then in order to react to those, I need to have a reducer logic. So in order to have the reducer logic, I need to write a switch case, for example. So for example, when I receive the event detect location, I need to alter the state object. Pretty much the thing that you do in Redux or you used to do, for example, explicitly before you have the React hooks. This, you could relate to that. This should be familiar, right? All right. At least someone knows that. OK. And in order to execute the side effects, you wrap them in use effect. Well, it's dependent on your case. You might run it in use layout effect or something, but use effect is the most common one. So again, inside the use effect, excuse me, I needed to conditionally see that which state I am in. So based on the state that I'm in, I needed to run certain things. So for example, if my zone state was in pending, then I needed to get the current location. And the way that the use effect works is that it works based on the logic that React handles as change detection. So it means that you give it a dependency, an array of dependencies, and when something changes there in that array, React will rerun the logic you put inside the use effect. It's called change detection. And the way it works is that it has it's a tuple of event and action. So it means that based on some received event, it runs a set of actions. But this will push your guards into the execution. It means that you need to conditionally query for the current state however you're handling it, and then run your side effects conditionally based on those. The same way that I did it here. So based on the current state, I was running certain side effect, and if the zone state was in the error here, then I was just crash reporting. As a side note, having guards you can't avoid guards developing UIs, but having them in execution is not really handy, because then it means that whenever you're trying to reuse a certain logic, you not even have to copy-paste that or abstract that somehow. Then you also need to take care of that guarding as well everywhere. You probably don't want your guarding in the rendering as well. I'm going to propose a solution after all. And it works based on the change detection, as I said. But the thing is, UI has always been event-driven. UI, from even the first days of, I don't know, 1970 or something, when Smalltalk was still a thing, and Alan Kay's team, they were trying to write the first graphical user interfaces based on those languages. They found out that event-driven mechanism for developing graphical user interfaces was a really good solution. And from those days, everyone just followed their way till now, which is 2019, when we still have event-driven user interfaces, because we are still subscribed to certain events in the DOM, and we run something. But the thing is, Alan Kay said that the big idea was not, this is about the first draft of his object-oriented programming. He said that everyone was focused on the objects, but the bigger idea was the messaging. This is still true about UI. If you think about it, UI is still event-driven. So it kind of helps us if we, instead of thinking about changing certain variables and reacting to those changes, we think about events. And we think about how these events can be organized or modeled in order to construct a UI. As an alternative, I tried to, after that, refactor this to reactive state charts. What are reactive state charts? Before going into state charts, let's take a look at final state machines. Final state machines are a mathematical model for computation that operate on top of a finite amount of states. And they always start from an initial state, and they can't be between states. They always need to be in one state. And they, based on the received event, they might transition to some other states. And this transition is a pure function. And they only react to events that are defined on the state. So at the construction time, you define the behavior. You say that if I'm in zone A, for example, if I receive a change in zone, always go to zone B. It's very dumb. It's not real, but I'm just trying to demonstrate the fact here. And explicitly, you define the behavior of your application in the construction time. It means that when you're trying to if you're trying to define and declare the final state machine, you're saying that my UI is supposed to work like this. I don't want any Easter eggs everywhere. The state charts, they are coming from an article published by David Harold, who was working on developing a UI for avionics systems in Israel for 30 years ago or something. They wanted to use state machines for managing that because it was a mission control project, and they didn't want to risk people's lives by having some bugs in the UI. Because if you had a bug in that UI, the pilot was gone after that. So they started working and modeling that by final state machines, but they soon hit some walls and dead ends because final state machines are there to model a finite amount of a state. But in UI, there are many cases that you don't have finite concrete amount of checkpoints. For example, consider that you are modeling an animation that tries to fill a glass of water. And you're trying to, based on some received inputs, try to model that animation in the UI. In filling a glass of water, you don't really have a concrete amount of checkpoints. You don't know how much is the volume all the time, but you know that it's either fill or empty or something else. That's called extended state. That's the whole idea of a state chart. So state charts are an academic paper that try to extend the idea of final state machines by adding some stuff to it so that it can be able to model UI. They have structures. It means that when you're developing UI, you don't have everything sequentially. You all remember command line applications, and you all use command lines every day as developers. Command lines were applications that were sequential, and in order to use that, you needed to know the syntax. So if you wanted to use the command line, you needed to know how the command line the operations work. If you're giving it something that was not valid, it would have just yelled at you. But today, UI is not like that. If you enter Twitter, you can do whatever you want in your keyboard. It's the it's the job and the duty of the developer of the Twitter application in order not to react to those events accidentally. So command lines were sequentials, but UIs nowadays are so complicated, they're not sequentials anymore. So they need to have a support for a structure. And state charts give you that structure. They have history structure for remembering where you were so you can pick it up later on. For example, a checkout process, you need to remember what was the choice of payment for the user if you're getting back to that state. They give you a hierarchy. It means that they give you nested states. All the states are not modeled separately. They give you, for example, in my case, in the HSL zone application, I only wanted to be able to watch the location if I have already once detected the zone. So it means that the zone watching state was a nested state of the zone if it was on the success part. I wouldn't have watching if the zone was in idle, in pending, or in error. I only wanted that to happen when it was in success. That's the idea of nested structures. And they have extended state, as I mentioned in the example, the glass of water. And they could have conditional transitions. It means that on the time of construction of the behavior of the UI, you can say that, hey, if you receive this event, if this is true, go to this state, otherwise go to that. So the conditional is already in the definition. You don't need to put the conditionals if-else's everywhere in your event listeners. And they explicitly define everything at construction. So it means that when the machine is constructed and you define everything, it just works. And you can port it everywhere. So in order to refactor that into reactive state charts, I had to think differently. In order to be able to model it in reactive state charts, instead of thinking about transitions and changes to certain state properties, I needed to think about states. I needed to think about hierarchy. So I figured, OK, my application, when the user opens it, it's probably in a state called preparing. These are just random names. You can just name it whatever you want. And in preparing, I try to figure out the support for geolocation. And whatever happens in geolocation, if I have support, cool, I'll go to ready, and I continue with the rest of my applications. Otherwise, I don't want anything else to happen. I just skip to error. But if you have support for geolocation, I transition to ready. So if I'm in ready, I default go to idle. I wait for you to click on the detection button. If you clicked on the button, I transition to pending. And when I go to pending on enter, I try to detect the zone. So I run a side effect called detect zone, for example. This detect zone will be a promise. It will either fulfill or resolve or reject. If it resolves, it goes to zone available. I have the zone. I can show you what the zone you're in. If the zone detection hits error, I go to zone error. And if I'm in zone available, I let you to subscribe to watching the geolocation. So if you can see, this nested object has let me to only watch and subscribe to geolocation changes when I'm already in the available zone. So I can't actually model it in a way that you can't use my application now after this refactoring and try to watch for geolocation changes and produce bugs when you haven't been in zone available first. So I don't let invalid stuff happen. And as you can see, I need to explicitly upfront think about all the error cases, because if I miss something, I would probably see it here. And in order to have some data to operate on, I need to have a context. This is the extended state I was talking about. I either have error or I have a detected zone. And in order to run a side effect when I'm in preparing, I want to detect the location support. So I run a service called detect location support. If the promise resolves, OK, cool, I go to ready. Otherwise, I go to error. If I'm in zone pending, it means that you already clicked on the detect button, and you're waiting for me to detect your zone based on the point you're in right now. So I invoke another service, which is just a promise, and it will try to get the point from you, and then try to detect the zone based on some geometry algorithm. And then if it fulfills and resolves, it goes to zone available, and the action that it runs is set zone. Again, it means that I only set your zone when I'm already in zone, when I'm going to zone available from zone pending. I'm not letting this set zone action to run in any other case. So no bug in that. The same for the error part, because here, if the detect zone hits any error, I will transition to the zone error state, and I will set the error for you to be shown in the UI. This is the same for zone available as well. If I'm in zone available, it means that, OK, I detected your zone. I can now let you subscribe to the changes of the geolocation. You can get to manually refresh, which is here, one of the specs I showed you. This is a manual refresh. So if you're in zone available and you're not watching for changes, if you manually click the refresh button, I go to zone pending again. I don't need to do anything. I don't need to copy-paste anything. The machine will just take care of it by transitioning to zone state, repeat everything else. I defined it once. I suppose it should work. Then whenever there is an event location change, I remember what the state I was in, and I get back. This is very useful because you might be able to refresh when you're not watching. You might be able to refresh when you are watching. So I need to remember what was your choice of watching when I'm getting back. Otherwise, I would reset your choice, and that would be really annoying and buggy. This is also another power of state charts in practice. They give you the history. Since everything was upfront explicitly defined, machine can remember everything and do time travel. It can also help go to future and tell you what's going to happen in future. It's not just Redux who goes back. It can go forward as well, because it knows what events it's going to react to in future. So the way you run the side effects, as you can see here, I'm saying that, OK, run this side effect for me, set zone, and send the notification. And surprisingly, this is the only thing I need to do for sending a local notification in a state charts. I don't need to take care of anything else. It will just take care of everything itself. I'll show you the code for those services later on, if there is time. So in order to execute side effects, any UI needs to execute side effects. Otherwise, it's not live. So in a state charts world, if you want to execute a side effect, your side effects can be categorized into different categories. It can either be internal actions, and by internal actions, I mean actions that update the data. So whatever action that is supposed to update the error and the zone in the case of HSL zone is an internal action. There are some external actions as well, things that Erlang calls them fire and forget. Means that, for example, logging, sending analytics, reporting crashes. They're like UDP connection. You don't really care about the response. You just want to send them. They're exactly external actions here. There are activities. It means that there are some actions we have in UI are background activities that need to be alive and running while you're in a certain state and need to be terminated automatically when you transition to some other state. For example, I need to watch for geolocation changes when you subscribe to it. So if I'm in zone available state and the internal state is also in watching, then I need to run an activity that will watch for your geolocation changes. It needs to be alive in background. There are also stream callbacks. They're pretty much the same as activities, but the difference is that activities don't get back to the machine with the data, but the stream callbacks will get back to the machine by the data. So in this case, I shouldn't use activities, but I should use stream callbacks, because I care about the geolocation change. If I didn't care about the response, I could just settle on activities. And the last one is invoke services. So invoke services are basically promises that will run and will either fulfill or reject. That's it. For example, sending notifications or checking geolocation support. These are invoke services, some running promises that you care about them, and they're not supposed to be alive and running. So, as I said, UI wasn't event-driven, and hooks take a path to change detection, and there is reason for that. It's because of the nature of event-driven nature of UI, they need to react to certain events. They need to change detect some changes in some properties to rerun your side effects because they're following a paradigm called state event. I'm sorry, they're following a paradigm called event action. It means that in react to certain event, they run a set of actions. But what a state chart takes as a path for modeling is that instead of pushing the conditionals and guards everywhere in your business logic, they try to have it defined already at the construction in the machine definition. So when they want to run an action in response to an event, they care about the state. They might not run it if you're not in the right state. So it means that they will run an action if and only if you're in this state and you're receiving this event. They're limiting everything. They're acting as a firewall. So you can't shoot yourself in the feet. And instead of taking a path for change detection, which is really common because React hooks are doing it, kind of different. Angular is doing it. AngularJS was doing it, as you remember. Some reactivity parts of Vue are doing it, but they're different. But the state charts, they take a state mapping. It means that, well, they have support for observables and stuff, but that's your own choice. They can just run with primitives everywhere. And the way they work is that they're just a map of states to events, and they run some actions in response to that. I may need charger. All right. Yeah. Well, there is one in my backpack. No, I think it's behind that. Yeah, this stuff happened at Microsoft Build as well. This is just a meetup, right? Yeah, that one. Thanks. I think I need to model myself as a state chart in order to fix these bugs. Thank you. Oh, yeah, thanks. Yeah. There is also an iPhone charger here. Okay. Thank you. All right. So instead of change detection, they map the state to events and they run the side effects. Thank you. So as some takeaways, when you try to model something as a state charts, instead of waiting for some changes and running something, you say what the state you need. So instead of thinking about transitions and what could change and react to those, you think about the states. You always think about what state you're in. If you need a similar case that has only one very tiny difference, that's probably a different state. That's not an if or switch case. That's a different state. Handle it differently. So you say what you need as a state, and everything else follows as defined. Because if you're in the right state and react to the certain event, everything will just, every valid action will run. And when you do a stuff and model it in state charts and state machines, things happen when they are supposed to happen. Nothing happens like an Easter egg. Nothing just pops out somewhere. Everything happens when you only define, you can only blame yourself if there's a bug. Or there is, okay, if you can either blame yourself or a developer or blame the platform for some buggy behavior. But most of the times in a state charts, when you run into bugs, the bug lies in a certain part of your definition. So you said it can have bugs. Also, invalid things become impossible because I'm not allowing anything else happen rather than stuff that are in the definition. So if I define it, it works. Otherwise, it doesn't. Also, it feels really safe in adding new features because when I was refactoring from hooks to state charts, instead of moving everything, I started small. I didn't put the watching and stuff. I just moved the zone detection. Then I added watching as a new feature. Then I added notification as a feature. And there was a bit of learning curve at first because I needed to think. And thinking is hard. But when I got the right model, everything just was really, really linear. I just added one string and the action was run. That's it. I showed you in one of those images that send notification was just one string in an array. Some lessons I learned while developing this DOM side project. Web is really broken compared to mobile, because I also made the React Native version of it, but I couldn't publish it because I didn't want to pay $100 to Apple. It's not good for environment. But comparing web and mobile, web is completely broken compared to mobile, because I had everything, like notification support and everything, down to the platform level support for mobile. It was just a matter of adding the right library. But for web, these are broken in the platform level. These are different from something that you might write abstraction for. These are just broken. Safari is a pain in the butt. Well, the first model was working on web as a progressive web app. Safari was just not working, not following. I don't know why. Even even checking for the support of geolocation was hitting runtime errors. I have no idea why. No one had. There was a bug. I don't know. Mobile Safari is even more pain in the butt. It was even worse on mobile, on the progressive web app. And one other thing that I learned was that state charts, well, they had a steep learning curve at first, but I think when I learned them, then it's fine. I think I lack of knowledge in modeling when I lack of knowledge in state charts. But they kept the logic the same. And what I mean by that is that, for example, say that you want to model a router in a state charts. You have your router defined as this. You want to say, OK, my initial route is main screen, and my context only has the list of all the routes that are available. So when I'm trying to construct a new router instance, I can just pass them optionally as well if you want. And then the state is that every route can be a separate state, because you can't be in different routes at the same time. And when I'm on main screen, I only allow go to about event. And when I receive that, I go to about the screen, and the action that I run is set route to about. And as a way to show you that how this abstraction in modeling using a state chart can make your behavior portable, I created a web router instance, and I created an Android router instance, saying that if you get your logic, since it's just a JSON object, it can be copy-pasted everywhere. This is exactly what I did. I made the logic on web. I copy-pasted to React Native, just changed the screens to React Native. It worked. Surprising, because I never coded like that. It worked. And that was really, I was happy after that. This is exactly true about state charts, because they are serializable. It means that you can, of course, define this action instead of being a string here. You can define it as an inline arrow function just there in the definition. But that would tight couple it to JavaScript. You can even port this and decode it in another language. That's the power of state charts. If you want to see it in action, I said this would be pointless if I don't show you how the application works. I had it somewhere, yeah. So this is the application based on the design system. And it finds your zone based on your geolocation. It's in zone pending now. And it says that your zone is in A. And you can manually refresh. That was a refresh event. And you can watch for live changes. And you might think I might need to run everywhere to test this, but actually there's a sensor test in Chrome. OK, come on, Chrome. Yeah. There is a sensor test in Chrome. So I stored whatever I want in different zones, and I just changed it here, and boom, it worked. Actually, this triggers this mocks the geolocation watch, so I can actually test it. It's an integration test. It works. And if I go to C, it works. And as a side benefit, I even got a better UX, because I wasn't asking for your permission when I didn't need that. To show you that, I'm going to go to an instance that I don't allow anything. I hope I'm not allowing anything. Yeah. I find my zone. I don't have any permission to run geolocation check or notification here. Just see how this prompts. This needs to get the geolocation permission from me first. It can't detect anything. Allow. OK. Yeah, it's because I'm in Berlin now. Sorry. No override. Let's rerun this, and let's say that you don't have any. Yeah, all right. This should give me A now. All right, I'm going to allow you. Nice, you're in zone A. I want to watch for live changes here. And then I want to go to London. It gets the permission for notification just here. It doesn't get it before that. That's the power. All right, let's get back to. Where's my slice? Yeah. All right, let's get back to this. So, okay, I'm pretty sure I had a demo, but it's not here. Thank you. Just a quick note, if you want to check the code, the order, the first attempt that was using React hooks is it's tagged as version 1 in the code base here in GitHub. The latest master branch is the latest refactor based on the state charts for web. And there's also a branch called RN that shows you React Native. Just clone it and just switch to the branch, do install the dependencies and run, and you'll get the React Native application. Thank you.
Okay, so any questions? Oh, there is one. Oh, I'm not throwing it. No, wait.
Hey. So my question is, did you use any library for state charts? I didn't catch it.
Yeah, that's actually a good point I missed in my presentation. I use a library called XState, developed by David Khorshid Piano, but he calls himself Piano. And yeah, that's an implementation based on the SCXML standard for state charts in JavaScript. But you don't need that if you're not relying on state charts. If you're just using FSM, final state machines, there is also a library unlike nested for the XState for FSM only. It doesn't have anything for state charts, but you can also just use switch map, like switch case or object mapping, just normal JSON object.
Yeah, I kind of know how it works. I was just curious about what you used in your particular implementation. Thank you.
God damn it, I catch it. But anyway, any more questions? Okay, it seems quiet here. Oh, there is one.
Hey, thanks for the talk. Just one question. Have you considered modeling the final state machine with streams or like reactive libraries like RX or something?
Well, you can do that, but that's not modeling actually. Because, well, okay. Also, I could mention another point. The way that final state machines work is that they still need an interpreter level. So they just compute some state transition for you. They're logic for transitioning. You could have done that yourself implicitly before by switch case and stuff, but now you can just replace that part with final state machines and state charts. They tell you that you need to run this side effect. They don't run it for you. You still need an interpreter level to execute those side effects. And that level can be Redux, can be RxJS, can be whatever else you want. Can be even outside of React. They're not even tight coupled. They're just framework agnostic. But you still need something. So you can get to run Rx for this. But Rx doesn't do the modeling. Rx runs that for you.
No, it does the modeling. Like you don't have to subscribe even. You can combine streams in different ways. Right?
Well, that was the point in the talk. The subscription is not the modeling part. Because if it was modeling, we were modeling for 30 years. We wouldn't have these problems.
Yeah, that's why I'm not talking about subscription. I'm asking, like, if you define all the possible signals, all the possible events as streams, subjects or whatever, observables in the end, and then you combine. So then the combination could be, like, depending on the inputs, could be in one particular state always, right? And that would be the modeling part. And yes, at this point, we don't even care if someone is listening in the subscription.
So you're telling me if you model in RxJS, for example, for reactivity, you don't get to send logout event when you're already logged out, for example. Like I'm just talking about invalid filtering. If you model like, okay, so consider that you have an app. Can we talk this?
Of course you can. I'm just
we can
here.
actually continue afterwards. Probably not.
Whatever works. Okay. So what I'm saying is that one of the huge wins of this approach is that it doesn't allow invalid transitions, okay? So like normal Redux, for example, it says that you have logout and login actions. They run side effects inside them, and you have states here. You say that is logged in or not. So instead of not running, like for not running the logout action when you're already logged out, which is unnecessary, you need to guard against it. You say, okay, if a state that is logged in is false, then only at that time you're not allowed to run the logged out action. Because if the user is logged out, you don't need to log it out again. So how can you achieve that with RxJS? How can reactivity solve this?
Use some operators like take, until, when, and so on.
Okay, so those operators are a functional reactive chain of the same guard. What I'm saying is that regardless of how you're doing it, you're either doing it with if, you're even doing it some other else, with some abstract decorator, you're either doing it with a chained function in reactivity, it doesn't matter, you still need to guard against it. What I'm saying is that you need to invalidate that, you don't need to run that and guard against it by some operator in Rx. Okay, but my problem is that part. I don't want to do that guarding. I don't want to allow that in the first place.
Okay, fair enough. Thank you.
Thanks.
Okay, any more questions? Let's take one more. Anyone? Okay, it seems like there is. Oh, you do.
So thank you for the presentation. It was super interesting, and your project is super interesting. But would you recommend using state charts in a real-world, large-scale application?
Define large scale.
What we are doing?
Well, we're not developing alone. So, like, as we're software engineers, so we need to do engineering. It means that we need to consider a lot of things. There are business requirements. There are client mainstream tech choice. There is team. There is learning curve. If those you can afford, sure.
True. Thanks.
Okay, so yeah, let's give a big hand to Farzad.
Thank you.
Okay, so right now I think we have sauna or something.
Yes, and we have more drinks here, and we were thinking about having first a ladies' turn in the sauna. And then afterwards we will have men's turn.
Okay, so let's have some drinks, talk, and have fun. So let's have fun.
And feel free to stay here and hang around.
Thankfully, nobody lost the head from you.